Hello everyone. The world we live in is a vast, interconnected web of life where ecosystems play a crucial role in maintaining balance. But understanding this balance requires us to dig deeper to examining the challenges, the innovations, and the changes happening right now. Today, we will be presenting 3 articles that shed light on our ecosystem and our reflective on the articles. Before that, let me introduce our group members, which is Fizani Azari, Izzat Zurafael, Muhammad Haris, Muhammad Izfar Hafiz, and our leader Yoshini. Without further ado, let's go to the first article. The focus of Article 1 is Citizen Science, published on April 14, 2020 in the Journal of Cleaner Production. This article includes the work of 5 authors. Introduction. After we read the article Channel of Collaboration of Citizen Science and the Sustainable Development Goals, the article explores how citizen science contributes to solving global challenges through public participation. It focuses on community involvement in achieving the United Nations Sustainable Development Goals, SDGs. So here are the key points from what we found. First, role of citizen science in achieving the SDGs. One of the key ideas we took from the article is how citizen science contributes to achieving the Sustainable Development Goals, which is SDGs. We found it fascinating that individuals without formal scientific training can play such a significant role in tackling global challenges. Second, enhancing data availability and quality. We are also found the article's discussion about filling data gaps, especially in under-monitored regions, stood out to us. We had never considered how citizen-generated data could be so valuable for policymaking and scientific research. Third one, collaboration across sectors. We found the emphasis on collaboration across governments, NGOs, and local communities insightful. It shows us the importance of teamwork and resource sharing in achieving shared goals.
Channels of collaboration. Firstly, representation in partnerships. And the purpose behind this is to increase the involvement in multi-stakeholder platforms for achieving sustainable development goals. The challenges they are facing is the limited institutionalization of collaborative efforts and the lack of infrastructure in some countries to support partnerships. Next off, the contribution to specific sustainable development goals that focuses on environmental sustainability, biodiversity preservation, climate change mitigation. And the gaps between these are the low participation in critical fields like agriculture, the uneven societal reach limiting the inclusivity. Besides that, policy involvement also are a part of the collaboration, where it is to contribute to evidence-based policy making and enhance public participation in the decision-making process. The barriers they're facing are lack of official frameworks for civil society integration into policy development. And other than that, education and empowerment is also part of their collaboration, where it is to promote quality education that align with sustainable development goals and to foster civic engagement among communities. The issues they're facing is the limited inclusion of sustainable development goals related topics in curricula and the insufficient training for educators and participants. Lastly, the data provisioning for monitoring, and it is to fill critical data gaps in national and global sustainable development goals monitoring frameworks. The constraints that holding them back are the ensuring data validity and accuracy and navigating their data ownership issues. For the Article 1 Citizen Science, we've done some reflection, and the insights we've gotten are such that of the many insightful points made in the article, one of them was the author discussion on how citizen science builds education and empowerment in communities. In the section focusing on engaging communities for localized sustainable development goals monitoring, The author highlights initiatives where individuals monitor locational factors such as air quality or water pollution and submit this data for scientific and policy purposes. While before reading the article, we thought impactful scientific research required advanced expertise and resources. However, this insight showed us that collective, community-driven efforts can significantly contribute to addressing global challenges. Inspired by this, we considering how these principles could shape our future work in architecture. For instance, we could involve local residents in assessing their needs during the planning phase of sustainable housing projects, much like how citizen science engages communities in data collection and problem solving.
We found the article insightful because it highlighted the power of collective efforts in addressing issues like climate change and education. We are also found certain ideas challenging, such as how citizen science can be effectively implemented in low-resource settings. So how it connects to our prior knowledge or experience. As a student studying architecture, we see parallels between citizen science and our architecture studies, where we rely on diverse inputs for a comprehensive understanding on motion in anthropometry learning, while citizen science emphasizes how collective contribution can enrich research outcomes. The articles made us realize just how important community involvement is in achieving sustainability. The potential contribution of non-professional data to large-scale projects had not occurred to us.
Hi, my name is Firzani Azari bin Muhammad Sabri, and I'm going to talk about Article 2 Overview slide. So the title of this slide is Science of the Total Environment. The author is Jordan Gakutan, Emma L. Johnston, Heidi Tite, Wally Smith, Graham F. Clark, and also published in Elsevier 2022.
So now, I'll be talking about the key points and arguments. The article discusses how plastics dominate marine debris on Australian beaches, making up 75% of the debris. Almost half, which is specifically 48% of the debris, comes from land-based sources like littering, while 7% is from at-sea dumping. For regional differences, it's noted that higher accumulation rates of debris were found along Australia's east coast, particularly around urban hotspots. Common debris types such as hard plastics, foam packaging, plastic remnants, and cigarette butts were the most common items found.
So next, we are going to talk about citizen science contribution. So the study highlights the role of citizen science project like AMDI in gathering data and tracking debris patterns. Next, data accuracy issues. The article addresses the challenges of data quality and introduces a method for filtering out poor data to improve accuracy. So the next one is recommendations. The article stresses the need for better data collections, standardized category for debris, and improve monitoring to manage marine pollution more effectively.
Now, I'll be going through Article 2 reflection slide. My thoughts and impressions after reading the article is, I was struck by how serious the issue of marine debris is and the widespread impact plastic pollution has on the environment. We didn't realize how much of this debris comes from land-based sources, especially littering. It's encouraging to see that citizen science can play a role in tracking this pollution, though the challenges with data accuracy are clear.
So the next one is how this article connects to my prior knowledge or experiences. So I've come across discussion about plastic pollution in the media and through environmental campaigns, so it wasn't new to me. However, the scale of the problem in Australia really hit home. I've also participated in local cleanups and understand the importance of community efforts in addressing these environmental issues. So the use of citizen science in this article was familiar, and it made me think about how we can all contribute to solving such problems.
What we found insightful are, we found the method of filtering citizen science data to improve its quality particularly interesting. It's amazing to think that small contributions from many people can lead to large-scale data that helps shape environmental policy. As for the challenge, the variability in data collection methods and the issues with inconsistencies were a bit concerning. It makes me realize how difficult it is to rely on citizen science without some standardization in the way data is gathered and analyzed. Future research should focus on this to make the data more reliable.
Hello, now let's jump into Article 3, which is Success Factors for Citizen Science Project in Water Quality Monitoring. Before that, I am Muhammad Isfah Hafiz and I am the presenter of the Article 3. The article had written by Aina Science, Aina, Sauna, Tamara, Jiwon, and Sabrina. The article published in 2020 by Elsevier BV. For the introductions, this article mentioned about problem, solution, and also the challenge and opportunities. The main problem is lack of water quality data, which is a significant problem because water is essential for human health and also the environment. For the solution, the article has one project called Citizen Science Project, which involves citizens in water quality monitoring. And for the challenge and opportunities, the project needs to analyzing and interpreting large amounts of data and also ensuring the data collected meets the scientific standards. Other than that, the problem has 9 methods which are compulsory for systematic literature review. Now let's talk about the results. The Citizen Science Project have 3 sets of design principles. The first one is attributes of citizens. These include citizen knowledge and experience, citizen awareness of environmental issues, and citizen motivation. Second set of design principles is attributes of institution. This attribution involved in motivation and type of organization involves. For example, the organization is universities, which can use their benefits to collaborate with local communities and other institutions. Not also forget the types of funding, which is the consistency of investment. Lastly, for the third set of design principles is process and mechanism. This includes supporting structures to ensure the quality of data collected. The process and mechanism also includes communication and feedback culture, which help the scientists to understand individualistic behaviors and lead for public understanding. Before the end of my presentation, let's talk about my reflection after reading the Article 3. The first one I noticed, citizens plays the main role in this project to be successful, the guidance from scientists and also the organization. I also impressed for the organization and institution to give their hands to support this project. To connect it with my knowledge and experience, I got that we don't need to use a lot of budgets to do scientific projects to be successful. We just utilize what we have in our surroundings. For the insightful and challenging, the method used for science data collected are significantly impact in our environmental policy, the variability in data collection methodologies, and the presence of inconsistencies is concern regarding data reliability. Future researchers should prioritize addressing these issues to improve data quality and reliability.
To conclude, citizen science plays a critical role in addressing environmental challenges and advancing the Sustainable Development Goals. From Article 1, we understand how citizen science contributes to achieving the Sustainable Development Goals. Article 2 demonstrates its effectiveness through a decade-long studies on marine debris, showcasing how large-scale, volunteer-driven efforts can monitor environmental issues. Article 3 provides a framework for designing effective citizen science projects that deliver impactful results. These insights highlight that citizen science thrives through fostering collaboration, empowering volunteers, and gaining institutional support. It bridges the gap between local community actions and global sustainability goals, making it an essential tool for promoting environmental stewardship and scientific literacy. That's all from us. Thank you.